Hey there, my name is Thomas. I am also known as Mr. Helmut on the interwebs, and I am one of the developers of the roguelike games ScourgeBringer. And I've promised on Twitter that I would make a video tour of all the tools that we made for ScourgeBringer. So here it is, and hopefully it's going to be cool for you. And of course, if you have any questions, you can ask them on the comments below or hit me up on Twitter, on our Discord, and so on. So before I begin, I'd just like to talk about the kind of programming language that we use, and do we use an engine, or why we use or not use an engine, because that's the kind of questions that I get a lot. And so to get straight to the point, I've programmed all our tech in C#, and we are not using a pre-made engine. We made our own over the year. So our company, Flying Out Games, has been going on for soon 7 years, and we made a few games, mostly 2D games, pixel art games, action game. And so we kind of built our own technology ourselves, and I'm mostly using a library which is called Monogame. Monogame is not an engine. It's mostly a wrapper that comes on top of lower level stuff like 2D, OpenGL stuff, Direct 3D. It manages also inputs and different kind of stuff, and it's built in a way that it is hopefully as cross-platform as possible. And so we use it to ship the game on all platforms. So our engines already shipped game on almost all consoles, PS Vita, PlayStation 4, Xbox One, Nintendo Switch, and all the thing. This doesn't mean that ScourgeBringer is going to be ported anywhere specifically. It just means that our tech has already been used for getting games to those consoles. So please don't look into any secret announcements into this video. But I believe some console announcements are going to be coming soon. And so why are we using Monogame, and why are we using C# over maybe some other engine? Because some comments I get a lot as well is, you should be using this engine because it's better than what you have been doing, and you should be using this, or why aren't you using that, and so on. So the main reply that I have to these kind of comments or questions is that we don't care about technology. We care about efficiency. And if I were to give advices to people who are aspiring developers or looking into a technology to start making a game, I would advise that you just stick with the technology that feels nice to you, where you are comfortable, and where you feel like you could be efficient. And it could be anything. I mean, just don't go with a tech that it seems fancy and everybody is talking about, because it kind of have like a trend bias. So the best is to just try everything that you can, and if something clicks for you, stick with it. It's the only advice I would have with this. And so why I did choose C# and Monogame, it's mostly because I have now more than a decade of 1 decade, not several, please. I have about 1 decade of experience in C#, even more, and I have almost as many years of experience working with Monogame and what was before Monogame, which was called XNA, because Monogame is an open source re-implementation of what was XNA. and I kept using it because this is something that's totally clicked for me, and I was very comfortable using it, and I love using it, and I just feel efficient. And every time we start new projects, there is always this question of, should we switch engine? Should we switch to another solution? And we always ask ourselves if we should or not. And it depends on the project. It depends on many factors. And it's always something to balance between what is the cost to switch to a new technology and to learn something that would make me as efficient and have the same expertise that I have on monogame and C#, to have the same thing on another engine, on another technology, over keep using the current technology, and is it suitable for the current project and team. And so far, it has always been in favor of keeping our own technology and keep building upon it, because that was just what felt the best solution. So I'm not against any kind of engine on technology. I am not like a diehard advocate of monogame either, even if I really like it. But it's just go with the flow and don't try to go with the trend. That's the only thing I can say. Okay, so now to the real deal. So maybe why you are here. And I believe over the last few minutes, you've been gazing upon this screen, which typically looks like a tile editor, except that things are moving and also are playing. So this is the main tool that I made and that we are using to make the entirety of ScourgeBringer. So it's cut down into a few functionalities, and the first main functionalities is the room editor. So in ScourgeBringer, I've already explained that, but I'm not sure if everybody knows about it, but every room is handcraft. So for instance, here are all the rooms that are in World 1. So there is about like maybe 100 of them. And once the game generates a world, the world itself, the topology of the game, the maps are randomly generated, not randomly, procedurally generated, because procedurally generating something is not the equivalent of random, because random is just like, random mess. But we don't want pure random. We want to have something smarter. And that's what we call procedural, because it comes with a few constraints that generation have to respect. And so each room are handcraft, because we want to have a fine control over the environment, and we want to have a fine control over which enemies we place and where, and what is the difficulty of each, and so on, because we want each room to be a cool challenge, and we don't want to be a random mess. So the editor itself for the room is very straightforward, because it's basically a tile editor. So on the right, I have my tile sets, and I have several pages of tiles, and I just have to grab them and to place them, or I can remove them and I can paint them more. And that's basically it. So simple as pie. And there is a few things more. You have a mode for everything that is colliders. So red blocks are things you can go through. Orange blocks are things you can jump through, but you can't. The enemies can't. And there is also other kind of colliders. So I can edit. I can, of course, remove colliders and place them on. And if I click several times, it changes color, because it is another type of colliders. And I also have purple and light purple colliders. These are the colliders of the world, of the fourth world. So if you know this world, you know that the bullets are actually going through platforms. And this is another kind of colliders that we made. So it's a specific collider. So if I go into collider mode here, you're going to see that the colors are not the same. So it really depends on what we want to do. And then we have everything that is doors. So rooms are connected by doors. And we can, if we want, place or remove doors. So for instance, I have this room be a left and right doors. I can place the door almost anywhere I want. I can place the north door. I want the north door. Will it give me the north door? Here it is. And I can place it everywhere I want on the scene. And basically the game is going to compute that. And when the room is going to be instantiated into the game, the game will connect the doors properly, or maybe going to remove some doors. For instance, this room can go into a dead end, and if it goes into a dead end, it's going to be connected only through one door. So the game knows that, and it removes the unused doors. And also I can change the background. So if you look at the background, it's very dim. So I don't know if you are going to see that very well into the video. But with just like mouse wheel, I can change the background. So it's just something that goes around all the graphics and so on. There is also in these tiles, as you may see maybe on the scene, there are a few tiles that are animated. And these are done kind of automatically. If you already use the tile editor, or if you maybe use something like RPG Maker, there is what they call auto tiles, or stuff like you grab a tile on your tile set, and when you place it, it's going to be animated. That's the kind of stuff that you are using, except that it doesn't work quite the same way, because we need more properties than just animation. And for that, we have files outside the editor. For instance, here I have my tileset4 JSON file, which is basically the tileset, the file that describes all the animated tiles that goes into the third world, I believe. No, even the tutorial. That was the tutorial world. So here you have several animated tiles, like when I go on grass and so on, it reacts to the player. And this is done directly into the JSON file. So here, for instance, I have my grass1 special tile. And this is where I basically tell where in the sprite sheet this special tile is, how many frames of animation it has. So for instance, it has 8 frames. It reacts to touch. So that means that if it gets touched by the player, an enemy, a bullet, or any kind of stuff, it plays the animation. It has a react frame time, which means that at which speed the animation, when it gets touched, is going to be played, and all kind of stuff. It can have destroyed particles, because you can destroy tiles, but that's something that we haven't used in production yet. Many stuff. And for stuff like the world tree, we even have special tiles that have weapons integrated in them. So for instance, these pipes, they blow out gases, and basically here they are, and it's completely integrated. So for instance, I just grab them on the sprite sheet and I place them on the map, and basically what it does a lookup into the JSON file, and it checks if it's supposed to be an animated tile, and if it is, it builds the animation, it allocates the weapon, and it puts it into the game. And with the mouse wheel, I can also tweak its timing. For instance, if I want to desynchronize each pipes or synchronize them in sequence, I can change their timing to get synchronized, or if I want to do something a bit more fancy. So for instance, if I want to place like 4 pipes and I want them to shoot in sequences, so I'm going to put one at 3 seconds, maybe one at 2 seconds, one at 1 second, and the last one I'm going to go down to 0 if I can get it correctly. Come on. Okay, so here it is, and here they are kind of synchronized. Yeah, so that are basically how or everything that is room editor works. And the other thing that you may have noticed is that it's fully playable. So it's directly an embed of the game itself. So there already is the game running right now in it. And I basically play with the gamepad. So it's really directly the game, directly with your character available, and you can do absolutely everything. And I can also play with enemies. So for instance, if I hit the test button, I am going to have like everything that spawns, and it works like the game. It will make everything that is the different kind of waves to work. And yeah, so that's super cool because we don't have to build the game, to export assets, and to run the game, to test stuff. We can test things directly into the editors, and that is like a very huge time saver. And when it comes to enemies, I have another mode into the editor that is the enemy editor. So here are all the enemies of the game. There are 2 enemies that are like reddish. These are 2 enemies that are not used in the game. There is even like enemies from what's to come World 5. So I'm going to try to not spoil too much. And World 5 is also already into the editor. Yeah, so when we want to place enemies, so we first choose the wave. So here we have wave 0. Wave 0 are the enemy which are already present into the game when you enter the room. And when you've cleaned it up, you can go into wave 2 and you just switch like this. So if I want in this room to have more devils, so I'm going to add 3 more devils. So here they are, and if I click on test, they are going to be there. And I can click reset to remove the current enemies. And well, yeah. So that is how we manage enemies. And we can go up to 9 kind of wave, but it doesn't mean that we are going to make rooms with 9 waves. But in fact, this wave system is going to be used to make kind of dynamic difficulty, but it's more like we are going to make variants of each room. One to be the target difficulty, one to be easier, and one to be harder. And it will allow us to, like, when we are going to generate a level, we are maybe going to pick 2 to 3 rooms to be super hard and 2 to 3 rooms to be easier, just to have something more with the generation, to be more diverse. And yeah, maybe in a future update, like doing something like a hard mode, we can do stuff like forcing the game to generate nothing but hard waves of enemies. And we also have 9 purple waves, and the purple waves have another kind of purpose, and I'm going to show you this in World 4. In the mini boss room. So here it is. So this is the room from the mini boss, and if I go into wave 0, I have my mini boss. And if you played the game, you know that this mini-boss comes with other enemies that appear over time or under maybe specific conditions. These are defined into the purple waves. So here they are. There are 3 or 4 of them. And basically what these purple waves are, they are what we call the reinforcements. So they are used mostly by mini-bosses for now, and they are used to spawn enemies if the mini-boss is in a tough situation, if you are like too good, or maybe if you want to spice things up a little bit. The mini-boss is going to call for reinforcements. So this is something that the AI of the mini-boss is doing itself. It's not something that the level is doing. It's really enemies that are kind of self-aware of what's happening and if they need help. And if they need help, they are going to go randomly through one of this wave and they are going to spawn it. And the game is not going to spawn multiple ones. And that's a system that is kind of cool because it allows us to cope with the fact that there is a wide range of players. Some are very good, some have more difficulties to grasp the game. And what we can do with this system is like kind of proposing the right challenge for you. So we are still tweaking this kind of stuff, but we are all using for this purpose. And some enemies also systematically spawn waves. So for instance, the mini-boss of the World 4 have 100% chance of spawning this wave after a certain time. And yeah, and when it comes to the enemies themselves, they are not made into the editor. They appear here, but they are all made into a JSON file. So for instance, this is the first mini-boss, what people used to call the Eye. And yeah, as you can see, it has a completely different name in our code. It's called Zarok, but it didn't end up to be this name into the game. And so this file describes everything about the AI of the enemy, every properties. So every animation, how the animations are connected. And so for instance, there are idle animation, charging animation, firing, stopping fire, charge blinking when it's smashed, appearing, disappearing because it's a teleporting enemy. And it has behavior. So for instance, it has a move type of teleporting, which means it's going to teleport, of course. It has an attack pattern to be randomly firing, and it doesn't follow the player. And it has basically 2 attacks. So it has 2 weapons. It has weapon ID 12 and weapon ID 13. It has charging time, and it has a mini-boss behavior of corner and center. So if you played this first mini-boss, you know that I'm going to show you. This mini-boss, here it is. So it appears either in the center or in the corner. And so that's basically one of the behaviors that we coded. In fact, every mini-bosses are going to have their own behavior. We are mostly not reusing behavior across mini-bosses. We ended up making each one have their own. And why we made all the enemies into a JSON file. On our previous game, Neurovoider, we wanted to have every piece of data into the game to have its own editor. So we had something like a very huge editor that was very complex and allowed us to craft everything within the editor itself. And what we noticed is that it was a huge piece of over-engineering because in fact things like enemy animation and even properties or setting the sound of an enemy is something that you are going to do mostly one time. And we just noted that it's purely useless to be looking into making an editor for data that you are going to edit only one time. And for this kind of purpose, we found that just sticking with the most basic text-based format is going to be just fine. And so that's what we are using. So we have the editor itself, and everything that is like a one-shot is going to be in a JSON file. So that is everything that is enemies, everything that is particles. So every particle in the game are just like one JSON object. And bullets as well. Everything that is animated tile within tile sets. And bosses, but not entirely. I'm going to come back to that. And yeah, so there is different kind of features into the room editor. So I can set the type of room. So there is anything that from the spawn, the mini boss, the boss, the shop. So here you have the boss room with our bodybuilder in it. Where it is? Here it is, our bodybuilder. And it's the same thing. So if I test the bosses, I can play the bosses directly in. And yeah, there is also the music that plays. Yeah, I just want this to stop. Stop the music, please. Okay. In different kind of room, for instance, also on the where is the boss door. So there is always a room that is dedicated to the boss door, and I can preview where the boss door is going to be, because depending on the setup of the map and how it gets generated, the boss door gets somewhere else. I have a function that is called debug backgrounds, and it basically removes the background and put just pure green, and that's to detect holes. So for instance, if here I missed to place some tiles, I want to be able to detect this hole into the map, because what happens is that you can see the background through it, and you may notice that the background is blinking when you get hits, and if there is a hole in the map, you're going to see it when you get hit. So we have this little function so that we can like grab stuff and place new tiles on it. I have another function to hide or show doors, and I have something that is called debug computer. So that is something to check if the log computers can spawn. So logs are stuff that you find in the game, and it gives you some lore notes and so on. And we basically spawn them at random. The game kind of look at where it can be placed and if it can be placed. So what this checkbox does is that every time I uncheck and check it, the game tries to place the computer somewhere else. So this is just something that we use to check if a room can spawn a computer and where it kind of spawn it, and if everything is correct. And I have the function to play music, so I can play music directly into the editor. So this is something we use to kind of get the feel of how it plays, how it looks, and how it feels. And for instance, Florian is using this a lot when he's designing new tile sets, so it kind of gets inspired by the music that Jonas do. And on the opposite, Jonas usually work also with mockups or maybe GIFs of pre-renders of what is going to be the tile set and how it's going to work. So it kind of, they both like emulate themselves together. And And it also works with battle music. So if I click on test, it switches to the battle music. And if I click on reset, it goes back to the chill layer. And yeah, so that's the first part of it, and it's already been like half an hour just to show you this. Hopefully the next part are going to be more straightforward, but it's one of the most funniest parts of this editor. The next part is what we call the maps editor. So it basically is our procedural algorithm that generate levels. And here you can see some sliders. So these are sliders that kind of have an impact of the topology of the map that we want. So for instance, if I want a map that produce only like straight corridors and very few branching paths, it's going to work like I'm going to tell the algorithm to like never spawn more than one door, and to avoid at all costs having neighbors. So this is what happens. It generates like snake-like levels. And this is what we use to kind of give, each level a kind of identity in what the levels are going to be generated. And so for instance, one world is going to be very corridory, one world is going to be more with several branches and forcing you to explore and so on. And there are also many other conditions that are hidden because they are not in the editor themselves. It's like, where does the shop goes, where does the mini boss goes, and so on. And we tried to do something a bit clever. So we used to have another algorithm which was previously based on the algorithm that was used in the prototype of Nuclear Throne. So it dates back from what was then Wasteland Kings. And when it was a game jam game, I believe, and I believe that back at the time there was, that was Trap, that made a blog post on the Vlambeer website to describe the algorithm, and we got quite inspired by it, and we used it in Neurovoider, and we started to use it again in ScourgeBringer, but it didn't produce results that we kind of liked for ScourgeBringer. And so we completely removed it, and I rewrote one to be more like what you would expect from a room-based roguelike. And this is it. And yeah, so each of the world has its own what we call topology. And we can have like pre-rendered visuals of multiple size and multiple mini-bosses, because in the final game we want some levels to have more than one mini-bosses per level. So the next function of the editor is to design bullets. So this editor is also fully playable. This is to design the behavior of each individual bullet. So it's not weapons, it's really one bullet. What does one bullet? And so I can define where the bullet emitter is going. I can modify its direction just for debug purpose. And I have different kind of weapons. So this is the laser, instant laser. What do I have else? Here we have flamethrower. It's not used in the game. Here we have weapons from World 5, which are not to be seen yet. And for instance, here is like big blobs. So this one is kind of cool to explain because it uses many of the features that we made for the bullet editor. So like I said, we have a JSON file that describes bullets, but it only describes bullets from a graphical standpoint. So it basically just tells how the bullet looks, if it's animated, and if it generates particles. And everything that is speed, acceleration, behaviors like clustering into smaller bullets and so on, this is going to be defined here in the editor directly. So here I have a lot of different kind of properties. So I can like select how they look. So that these are all the JSON entries, and I can tell if it's time to leave. So the time is going to be staying alive, and because every bullet expire after some time. I can define a behavior, if it's a laser, if it goes through enemies, if it rebounds. So here we have a rebound of 1. So that means that the bullet will rebound 1 time on a wall before exploding. So if I want to make them rebound more, I'm going to put 2. And as you see, it updates live and the bullet is going to rebound 2 times. I can define the rebound spread, which means that when a bullet rebounds, it's not going to have like a perfect angle. It's going to have some kind of spread to give it more randomness, more life to it. It has also a restitution. So if you know a bit about physics, when something rebounds on something, it has like a restitution factor depending of how much energy is going to be absorbed or loss in the contact. There is nothing like a physics engine behind ScourgeBringer. It's all like handmade kind of physics tricks. So it looks like physics, but it's not physics. There is a clustering factor. This how many bullets it's going to be clustered when it explodes. So here it's 3. But if just for the fun of it, I want to be 30, I can just tell that. And it goes 30. And different kind of factor, like what is the angle between each bullets that are going to be clustering, what is the spread again, and shift and so on. There is a collider radius, because if I display colliders, so the red thing are the collider. And I can change the size of the collider to be, well, sized properly compared to the bullet. Explosions, I can define explosions. So for instance, if I go into the rocket launcher, here is a rocket. So the rocket has different kind of stuff. It has debris, it has an explosion itself, and that's basically stuff I can define. So I can define if it also leaves flames on the ground, because here you see there is still flames lasting, so that is a property that I can set in the editor. This bullet also is very interesting because, as you can see, it changes its trajectory, and this is done with what we call actions. So we can kind of script every bullet. So for instance, this bullet has 3 different actions, which is to change its direction after some time. So, and that is what goes into like the serpentine pattern. And then the last action, it has a go to 1, because each action can tell to which other action it can loop back or loop forward. And this is how we can do complex stuff, very complex stuff. This bullet engine is very powerful. We can really make crazy stuff like bullet hells and so on. That's not the purpose for what we want to do with ScourgeBringer. That doesn't mean that ScourgeBringer is going to be a bullet hell, but it's just that we needed that to be this powerful for us to move forward. And yeah, and once we have one bullet design, we combine bullet together and other kind of stuff to make a weapon. And for instance, this is a shotgun, so it fires more than one bullet. But there are more interesting stuff, maybe here, for instance. So as you can see, there is a lot of blue dots around my center weapon, and these are what we call origins. And origins are where the bullets are actually going to be fired from. And they also tell what is going to be the direction of the bullet compared to the center of the weapon. And we have a tool which is here, which is a bullet origin helper, and it allows us to like make patterns of bullet origin. So for instance, if I want like 10 origins, I want them to be 5 pixels from the center, maybe more, 10. And as you can see, it updates live on the preview box. And I want them to be separated by 15 degrees. And I can just like click on replace, and it's going to replace all my origins. And I can work with this. And so it's also kind of complex. This one is quite complex too, because these actually spawn enemies, and actually in the game enemies are spawned from bullets. So we use the bullet system to carry enemies in them, and when they explode they spawn an enemy. So that's in the bullet stuff that we define which enemy eventually gets spawned and so on. I want to clear preview, and I want to... What can I show you specifically more here? We can also have rotating weapon. So I don't know how to show you this one, but we can define weapons that rotate on themselves. And for instance, if you know, I'm going to show you the enemy. So if you know this enemy, when it starts firing at you, it does this. So it does like a full moon. And this is done directly in its weapon. In its weapon, we have a property, I don't know if I can, it's this property here, everything that is rotation. So we have a rotation symmetry, which basically tells, I can, for instance, put follow player, which means that the enemy is going to be trying to aim at the player in the direction it is, depending of where the enemy is placed, where the enemy is, and so on. And yeah, and then I can apply a rotation and a rotation speed, and maybe also make a scene out of it. So it means that the weapon is going to go back and forth while doing stuff. And for instance, we can do stuff like, I don't know if this one is, no, these are tests. But for instance, this is kind of funny stuff that we can do, but it's not actually used in the game yet. Yep. One of the last functions that we have in the game is the boss editor. So this is maybe the most impressive part of the tool that we made. And so basically what we have in our JSON file for the boss is just this, what we call the idle frame. I'm going to remove this. And so this is a composition of multiple sprites. So for instance, if I go into the idle and just grab the head, so as you can see, the head is an individual sprite, and each part of it is. And then we have a timeline, and this is basically how we build animation. It is timeline based. So for instance, this is the idle animation, so I can keep it playing. And as you can see, it has the hand moving and a little head bobbing. And for instance, I can define over my timeline some keyframes. On it, I want to apply special positioning, rotation. So for instance, if I want the head to be here on this frame, I just place it here. And if I go play back the animation, the game is going to interpolate each individual frame into this animation. And so this is how we design animation, and we can do all kind of fancy stuff. We can also, I want to define a rotation, so I'm going to put a rotation keyframe here and also a keyframe here. And here I'm going to rotate this. And so now it goes with a rotation. And so it's very simple and very cool to use, very powerful, because it allows us to do all kind of animation. And maybe the most impressive of all is the Night Weaver boss, which is a spider. And this one is kind of complex because each individual bone is an individual sprite, which means that, for instance, I can grab each individual leg part and animate them. And then they are interpolated, and this is what makes movement so natural. And we don't have to like redraw each frame of an animation. So that is a very powerful tool, because we just have like to design the idle frame of an enemy, and then we go through all the animation. And we mix that with sprite-based animation. So for instance, if I go back to the bodybuilder and go into his right punch attack, if you look at his hands, you can see that the sprites of his hand are changing. And we mix in fact, the timeline-based animation with also frame-by-frame pixel art animation. And we can define each frame also in this timeline. So here you have a line that is called sprite. And I can just like, with my mouse wheel, change on which frame it should be using. And I also can make interpolation and so on. The other cool thing I can do is that I can define curves. So for instance, I want this part to be moving along this curve. And this curve, I can make it be, in fact, a Bezier curve. So it's a spline. And I just can like grab the weight of the spline, and I can just like very easily make something more than just a line. And this is what allows us to make also very fancy movements, and something that doesn't look like to be, pre-animated. And it's very useful. And of course, I can also define other kind of easings. So if you know what easings are, it's more like, if you're familiar with stuff like in Unity, it's often called twinning, because there are very well-known library like DoTwin that allows you to do this kind of stuff. So basically, these are all kind of twinning that you can do. So it's basically making movement less linear, making them bouncy, making them like to accelerate or decelerate at the end of the beginning, and so on. And the bosses, basically what we do is that we design all of their attacks. So for instance, this is one of the attack of the Candle Mask. And then in the editor, we define how they are chained together. So we have here what we call an attack table. And this is text-based, and we basically write down what are the conditions. And for instance, I want this attack to be fired upon this condition and to be followed by this one and so on, or to never be followed by this one. And this is how the boss react in game. And then we can also place the boss directly into the editor. So for instance, I want this boss, I can put a preview map just to test it in a real situation, in a real map of the game. And I'm going to click on play stop, and I can directly check the boss. I can play it, and I can also see the timeline working. So I can see and debug right into the editor to see how the boss work, if the animations are working correctly, if everything is changed together properly. And if it's not, I just grab my mouse and I click directly right into the timeline, and it's going to pause where it was, and I'm going to be able to debug directly this animation at this very moment. And so this as well is also like very useful, because we can design, test, and implement everything in the same place and at the right moment, without pausing, without rebuilding, without like modifying anything. And yeah. So everything has been handmade. So something I forgot to say is that the editor is the UI of the editor is made with something that is called Windows Presentation Foundation, acronym WPF. It's something that is only available on Windows, and it's a UI toolkit from Microsoft, and I love it a lot because it's quite powerful and very easy to use. And the timeline itself doesn't exist in WPF, and I had to custom build myself. So basically what this is a WPF canvas on which I have drawn rectangles, lines, circles, and text. And I basically created this component, this timeline component. And it has multiple functions, so you can animate animations, of course, but I have other modes, which are the weapons. So I basically can set sequences of which weapon fires when throughout the timeline. I have the same thing with particles, because, for instance, this enemy has small particles of screen shake, because screen shakes are treated as particles. So I can emit particles, which are in fact fake particles, but they produce screen shakes. And I can also define weak spots. So each bosses has colliders. So for instance, here in blue, this is the weak spot of this enemy. And I can tell throughout the timeline when does this boss is going to be vulnerable, and when does this boss is going also to be, when you can going to be like smashing it, or when it's going to be its weakness. So this is everything that we use so far here. And so these are all the main functions of the editor. We have a few more of them. These are options that we very rarely use. We can debug skills. I can set our skills for the character just to test different kind of combination. I can hide the UI and set something that we call pixel perfect. And this basically fully emulates the rendering of the game. And this is, for instance, what we use to capture GIFs. So I fire up Scream to GIF, and I use this to like capture the perfect GIF. And I just have to set is this here. I capture stuff. I play a bit. And when I'm done, I click on stop. and I have my GIF that is captured, and I just have like to clean it up, maybe resize it and so on, and save it as a GIF and post it on Twitter. And very convenient. The last thing is the analytics. So in the game, there is a setting in the settings of the game, obviously, that asks you if you are okay to like share your game data with us. So these are fully anonymous. We can't do anything with them. I mean, from an identity purpose. There is no IP address, there is no name, there is no thing about your computer. We don't know anything. We just grab stuff from the game, which are how many HP do you have, where are you in the game, what room did you clean, and the kind of stuff. And so we have a lot of data. So for instance, this is a dump I've just made of the data that we have. So we have like 600 megabytes of data. So that's something like more than 3 million traces of game data. And so it's only the data from the people who enabled it. And that's really not all players. So it's really like a small number of players. And from this, we can get many kind of data. So here it's like crunching all the numbers and trying to get many data from it. It's clean it up. It remove cheaters, because there are people that are using trainers or cheat engine and so on, which is cool. And we clean them up. We remove them from the data because they most obviously produce data that we don't want to get into our analysis. And then I can check all kind of data. So I don't know if you are familiar with everything that is like statistics and so on. So these are box plots. And box plots are a way to visualize data that is very convenient, because it gets you right into what you want to analyze. It removes everything that is outliers. So for example, if you have a group of players that are extremely good, you most likely want this to be out of the data, because if they are way too good, they are going to completely wreck everything that is under data analysis. And on the other spectrum, you also want to filter everything that is players that didn't play much. So for instance, for us, for the data, we remove any data from players that played less than an hour. And many kind of stuff like this. And so we have like statistics on playtime, of course, how many runs player have made, at which world they are failing the most. We have data for each world, individual world. We know how many attempts it takes to reach a world for the first time. We know how many HP you lose in each world. How many HP do you have once you've beaten the boss? How many max HP you have? How many money you earned, how many money you spent, how many skill points you have once you reach the world for the first time, which is very useful to balance the skill costs. Everything that is bonuses, sword damage, drone damage, maximum ammo bonus, reload speed. And we are able to know everything. We know how many players reach which world. We also know which blessings are the most used. We know which weapons are the most used. And this is all very useful, because we don't want to use this data to make the most perfectly balanced games, because that's not the purpose of a roguelike. A roguelike that would be perfectly balanced wouldn't be fun, because all the salt of a roguelike comes from having like winning and losing strategies. And it depends. It's really situational. And if everything was perfectly balanced, it means that any single run that you attempt is going to have like the same ending to it. And that's something we typically don't want in a roguelike. We want to have some more serendipity and more the RNG. So we want RNGs to be part of the run. And so what we do with all of this is just to check if there is nothing completely wrong. So we just check if things are kind of in line, and we don't want like something to be completely off and ruining the experience. And it's also something that we check to know if new players get into the game without too much hassle, because it's very important to us that people get into the game easily, and then we can craft a very progressive and higher difficulty. So we are mostly looking into word stuff, and we try to like smooth out very rough edges. But everything that is within an acceptable range of being far from the norm, it's kind of okay to us. So it's really not to make a game super flat. That's not interesting. Just checking if everything is fine. And the other interesting thing with this analytics is now that I have loaded them, they also appear in each room, which means that, for instance, we know that in this particular room, there are 40% chance that you are going to lose 1 to 2 HP. And this is very useful to us because it allows us to know if there are some rooms that are overly easy or if there are some rooms that are overly difficult. And when they do, it allows us to like maybe sort the different enemy waves to make them, to paint them more difficult, to paint them more easier, and just so that the algorithm that is going to generate the level is going to be able to craft things properly, depending of what kind of challenge we want to do at that moment. And it also allows us to check if everything is fine with bosses. So for instance, here we know that 97% of players are getting hit on the first boss, and they lose between 3 to 6 HP every time they run into the boss. So this is kind of an acceptable and normal experience from a boss. So it allows us to check if which boss is going to be more difficult than the other. So for instance, if I go into World 2, I can see that the second boss has 95% of chance of getting hit, which means that maybe the second boss is a tad less difficult than the first one, maybe, but it's something that we're going to be required to analyze more in depth. So it's not just like trusting the numbers for just what they are. And yeah, so we know about how the game is behaving. So it also allows us to balance the player feedback. So we have a feedback system into the game, and we also have feedback system into our Discord. And this allows us to know who are the player who give feedback. I mean, not in the way that we can identify them, but in the way that we kind of know where they are on the statistics. So, for instance, if going just to change that, what I mean is that if there is a player that drop by and tell us I have 500 hours of play, and we know for a fact that this player is among the outlier of the data that we have, because we know that it's behind our box plot and it's not within the core gamers. And so what that means is that if that players drop by and tell us that this boss is absolutely easy and I've wrecked it in 2 seconds, and then we go into our statistics and we check that and we see that like 99% of players are fully unable to do what that player did. And so this allows us to like have another view on the feedbacks. So this player told us that the boss is too easy. And so it's not something that we maybe want to consider as a relevant feedback for this kind of experience, but it's maybe a feedback that we are going to use for what we are going to craft later for an hard mode, for instance. So it's more a reference that we are going to put in a different box. That may be another feedback. So it just allows us to know in which boxes we should sort our feedback. And this is very important because it's usually your best players that are going to give you the most feedbacks. And it's very difficult to balance a game because it gives you the impression that your game is not well balanced, but in fact, it's only your best players that are going to give you this feedback. So it's just a matter of identifying what you are actually trying to do and who are those people and how can you respond to them without maybe disrupting the experience of other players. So it's more about the way how we see it is that we try to segment the experience. We have a base experience that we want to be accessible to core players. And we are going to craft more challenging stuff for the 5% of player who really want to do really hard stuff. So it's not about making a game easier. It's more about knowing how to segment stuff and which kind of challenge you want to craft for which kind of players. And yeah, so that's basically it. Yeah, and it's 1 hour. Yeah. So yeah, we went through it. So I hope that you are happy of what I've been able to show, that you found it interesting, and yeah, hopefully it was. And I believe that if you are still there, it probably was. So that's it should be cool if you went through it. Yeah, so this is basically everything I can tell you about all of the tools that we made for the game. And so basically we craft the game from there. And yeah, it's maybe going to be one day the kind of tool that we are going to publish for maybe mod support. This is not on our schedule yet. And we want first to release the full game before considering it. And because even though this tool may look like to be simple to use, they are very bound to our engine and to the data that we have behind. And we need to separate it from the game so that you can craft mods that are not going to disrupt the main data of the game. And for now, this is something that is absolutely not done. And so this may be the next evolution of this tool. And yeah, after the full release, not before. So yeah, thank you very much for watching for making it through all this video. And yeah, if you have any questions, any comments, or anything you want to know about our tool or anything, or how we design stuff and why, feel free to ask it. preferably on Twitter or on Discord, because I am likely going to not be very much around the YouTube comments. So yeah, I invite you to drop by Twitter and our Discord. I'm going to put the link in the description, so hopefully you are going to be able to find us back pretty easily. And yeah, thank you again, and thank you for the super cool response to the different kind of stuff we already posted about our tool. And yeah, many more stuff to do with this, and yeah, ScourgeBringer definitely not done yet, so many cool thing to do. See you around, and yeah, take care, and of course, stay safe.